Assalamualaikum students, welcome to another video of study with ARS. Today's our topic as dipole movement. So starting with our topic, okay. So di means basically two and pole means charges, okay. Pole means charges, okay. So the full meaning of dipole is two charges, okay. And this is a property in molecule. Property of molecule. What type of molecule? Because there are two types of molecule. One belongs from 7A group called homomolecule or diatomic molecule, which will make a bond with itself, and the other one is heteromolecule. Okay, so in homomolecule we are having same ratio of electronegativity between the atoms means, for example, if there is an atom like oxygen, okay, and there's another oxygen, okay, so the electronegativity of oxygen is 3.5, here also 3.5, so the same electronegativity, and so that's why there will be no any dipole movement. And the definition for electronegativity is to attract the shared pair of electron. The force which attracts the shared pair of electron means oxygen. If there would be another atom instead of oxygen which is having a less electronegativity, then oxygen would try to snatch the electron of that specific atom, and so that process is called electronegativity, and that occur due to the charges of oxygen, okay. And so now here homomolecule, because they are having same electronegativity difference between the atoms, so that's why they are not having any dipole movement, free from dipole movement. And here there are there are different electronegativity, there are different electronegativity, okay, let's write only En, okay, different electronegativity between atoms, so which occurs any atom to means try to snatch the electrons, okay. And the different molecule means, like here we have got HCl. These both are different. The electronegativity of hydrogen is 2.1 and the electronegativity of chlorine is 3.00, okay. So they are having a bond between one atom, and a single bond is there, single covalent bond, and chlorine is having much more electronegativity, because the difference of electronegativity between hydrogen and chlorine is 0.9. So chlorine is having that much more power to snatch the electron from the hydrogen, and when it will try to snatch the electron, there will be a partial negative sign, okay. And here hydrogen will be getting a partial positive sign, okay. So this one method is considered to be in a heteromolecule, and they are having different electronegativity, and because of that they are in heteromolecule. Example of heteromolecule is HCl, and dipole movement occur, okay. And here the electron will be moving towards the chlorine side, and here will be the positive sign, cause hydrogen will be getting a positive, and here will be a negative. So that's the only the representation of dipole moment we will be stating furthermore. Okay, so do not get confused here. And here these are the properties of heteromolecule, and here the dipole moment occurs. And let's talk about the dipole, means in which sign it can be represented. So there is a special sign for dipole, which is a mu. It is a mu sign. Okay, so dipole moment is simply represented by mu. Now let's look at the key point for dipole moment. It's the property of molecular property, molecular property, and it held between which types of molecule? Heteromolecule, heteromolecule. Why between heteromolecule? Why not between that one homomolecule? Cause of different electronegativity, different electron different electron negativity. Okay, and the example of heteromolecule I have given, but will be given now. So let's consider that HCl. Okay, this is the example of heteromolecule. There are lots of heteromolecule like HF and HBr, etc, etc. Okay, and okay, so now this is only a overview of dipole moment. Let's study in a further way. So dipole moment is directly proportional to, here is dipole moment is directly proportional to electronegativity and inversely proportional to 1 upon theta, means the angle. And with this thing I have cleared in my previous video. If you haven't watched, then watch it from there. Okay, I will not be explaining everything in this video. Okay, so that's why if you are getting any confusion, then you can watch my previous videos. Okay, so here this is the relation which we will be having in dipole moment. So let's means drive the formula of dipole moment. Okay, so it is between the charges, and you know that if there are charges, then there is a bit of distance as well. Let's assume that it's the atom A and it's the atom B. Okay, with the different electronegativity. Okay, and for example, let's took a rough idea that they are having a distance of 1 angstrom. 1 angstrom is the unit of distance. Okay, which is equals to 1 angstrom is equals to 10 to the power minus 10 meter. Okay, for example, they are having a distance of 2 angstrom. Okay, this is a rough idea, remember me. And they are having the electrons, they are sharing their electrons. So if they are having a different electronegativity ratio, then means uh, one of them will be trying to snatching the electron and will be getting a sign. So there will be, for example, B is having a larger sign, so it will be larger electronegativity, so it will be getting a minus partial, and A will be getting a plus partial sign. Okay, so here the electronegativity is different, and the electron of A atom will moving towards the B, and here this vector will be there, and this vector represent that electron is moving towards which side. Okay, and dipole moment is a vector quantity. First of all, I need to tell you this thing: dipole moment is a vector quantity. Dipole moment is vector. Why it is vector? Because direction is properly there. How direction is properly there? Because if there is a positive and negative, then there's a thing that positive will try to move towards negative sign. Okay, and here in homomolecule we are having zero diffraction or zero dipole moment, and here the dipole moment is not equals to 0 in hetero molecule, is not equal to 0. Let's look at here. So what I was doing here, I don't know, I forgot. Okay, so now let's move on the example. Yeah. First of all, I need to drive the formula. So yes, dipole moment is having means distance, and they are having the magnitude of charges. So the simple formula for dipole moment is q multiplied by r for radius, q for coulomb, oh no, q for charges, q for charges, r for coulomb charges. Okay, charges, and radius, the unit for dipole moment is cm. Okay, and also there is one more unit called dpi. 1 dpi is equals to 3.33 into 10 to the power minus 30 meter, no sorry, centimeter. Yes, 1 dpi is equals to this value. Okay, this is the bigger value. Okay, so now let's look at in the one example of dipole movement. Okay, for example, here we are having CO2. Okay, so in CO2 molecule we are having a linear bond. First of all, remember one thing, that in dipole moment, uh, uh, between linear, trigonal, comma, trihedral, tetrahedral uh, molecular shape, means these molecule will be having a value of diffraction, dipole moment will be 0. Okay, so why there will be a 0, then I will be telling you in here. Okay, after some time. Okay, this is just an example of CO2. Okay, linear molecule is not like this. the this is like this. Okay, but if you look at it, the means practical way, then both the atoms, both the electrons of carbon in a 180 degree, so they form the like this, oxygen and oxygen. Okay, so this is the means linear shape of carbon dioxide. Okay, so now uh, um, in oxygen is having a more electronegativity, 3.5, and carbon is having a less electronegativity, which is 2.5 or 2.8, I forgot. Here the electron of carbon will be moving towards oxygen, and here also the electron of this one carbon will be moving towards this that one oxygen. So both are vector, and if you look at according to the law of vector, if the vectors are moving towards the opposite sign, then they will be cancelling out each other. So here the dipole moment will be equals to 0. Both will be cancelling out each other, and thus there will be no any dipole moment. Okay, these both will be cancelling out towards each other. So let's look at one more example and a last example. With this example, I'm going to end this video. Okay, so for example, here we have got hydrogen, here we have got fluorine, and the electronegativity of fluorine is 4.0 to 2.1. And here we have got electron. The valence shell of both atoms are having one electron, and so that's why they form a single covalent bond. Okay, single covalent bond. And fluorine is having a more electronegativity, then it will try to snatch the electron, will be getting a partial, and hydrogen will be getting a partial positive. So this electron and will be fluorine will try to snatch it, and will not be successful, because there is 2.1. Can be or cannot be, that depends on the hydrogen. Okay, there's another topic, we'll see you in the another video. But here this one, there will be a means dipole moment, cause the electron of hydrogen will move towards this side, not completely, but there will be a dipole moment, because there is only a one vector, no other vector is there to cancelling out this one. So that's why the dipole moment is not equals to 0, there will be some dipole moment. So hope you guys have understand this lecture. We'll see you in the very next video.